Yeah, hello from my side. First of all, I have to say thank you for the invitation. My name is Daniel Mitrovic. I'm the CEO of KITEO. KITEO is a company which is based in Austria. And as you can see, my surname is Mitrovic, so I'm a typical Austrian. So my mother is from the Czech Republic and my father from Serbia. First of all, I will give you a short overview in the next 30 or 45 minutes regarding the topic human-centric lighting. It's a special theme in my opinion in the lighting industry, and I will give you an overview regarding our philosophy, also the company, the products, and maybe also a lot of design impact. So our company, let me say Lumitech and KITEO, were founded in 1997 in Austria. It was a spin-off of the Technical University of Graz. And the first application we provided were to define patents to realize LED solutions, but only simple white LED solutions at the beginning of the 90s. In the year 2007 there was a big, let me say, jump. So we did develop a special technology to simulate in an artificial way the natural light. So in my opinion, the natural light is the best thing we have, so it's for free and has the best quality and the best spectrum. So in the year 2009 was very important for us, so we did found the company KITEO, and KITEO is once again, let me say, a lighting design company and also a producer of whole luminaires. So we also have a lot of scientific cooperations with a lot of universities all over the world, especially with Bartenbach Lichtlabor. It's one of the biggest lighting designers and scientist institutes in Europe, or let me say all over the world. And we have a lot of research developments together with them, especially in Austria and especially in Germany. So light is not always the same. We heard it in the last presentation. So when you see a typical course of the day, you can see in that different moods that in the morning we have always a very warm situation. So the color temperature, as we heard, is very warm and very red dominated. In the middle of the day, let me say, or in the noon, the color temperature is very high, so the bluish color is very dominated, and in the evening it's otherwise the red color very dominated. So we have a big shift in between the color temperature all over the day. So when I switch to the color temperature all over the day, you can see there is a curve. So I think it's a sunny day and no clouds, no smog, no moisture. So you can see the color temperature is shifting all over the day in between 2500 kelvins for especially, and also between the highest point, let me say, is close to 10,000 kelvins, and in the evening it degrees also again to 2500, 2700 kelvins. So you can see there is a big shift in between the color temperature all over the day, and it's a natural procedure, let me say. So when we have a look in the normally daylight spectrum, let me say, it is inspired by the sun, and you can see the typical sunlight spectrum is full, so you have a very high color rendering index up to 100, and in comparison to that you can see the spectrum, for example, of a fluorescent lamp. So you can see it's not a continuous spectrum, and that's not good for the perception, because the concentrate level will decrease all over the day and you will get tired faster and faster. So what we have done is to develop a technology which allows us to, let me say, copy or to identify the natural daylight and to bring into indoor lighting solutions. What is very important to know, a lot of the things you have heard in the presentation before, let me say, the circadian rhythm depends on two hormones, and the special hormone, in my opinion, is the melatonin. So we need melatonin to sleep, and we need otherwise cortisol to be active. So we have a shift in between these two parameters, and it depends very intensive on the daylight. So as you can see here, when the color temperature is very high, so the melatonin suppression is also very high. So you will not feel very tired when you have a very, let me say, high color temperature lighting situation. For example, compact fluorescent lamps do have a very high blue index, and so they will suppress melatonin to the max. So, for example, 3 different moods. So as you can see here, at 7 a.m., maybe the color temperature is close to 4000 Kelvin. It's not too red dominated. And in the middle of the day, for example, 7000 Kelvins. And in the evening, 2500 Kelvin. So I do fully agree. It depends on the application. And all over the applications, maybe you have different kind of curves and different kind of lighting scenes. So it depends also on the intensity and the quality of light inside your room. So in summary, let me say, you can see it here normally, but it's not always true. Maybe you have heard in school, inside the eyeball there are the cones and the rods. One of them are responsible for the color perception, and the cones are responsible for the intensity perception. And what is very interesting, since 12 years, a lot of scientists find out that there is a third receptor in the eyeball, and this receptor is responsible to stimulate the wake and sleep rhythm. Let me say the circadian rhythm. And this is the play line, let me say, to define the natural daylight to an artificial, maybe LED system. So what we have done, you have seen the slide before, we have defined a spectrum. You can see it here, spectrum of human-centric lighting. It's also a continuous spectrum in the same procedure as the sunlight spectrum. So we have a solution to copy the natural daylight, let me say, into indoor rooms, but without the damaging UV radiation and without infrared. And what is also very interesting to know, we are able to shift the color temperature stepless in between 1800 and 50,000 Kelvin, from the red dominated to the blue dominated, without the shift in the color rendering index, because our color rendering index is all over the time bigger than 90. So, for example, you can see here a typical PCB, a typical LED board. You can see we are working with a 3-channel technology. Maybe you have seen solutions with human-centric lighting or tunable white, only with warm white and cold white LEDs, and you can shift the color temperature between warm and cold, also stepless. But our technology is a special technology. We are working with blue, red and mint LEDs. They are calibrated, and so we have the possibility to have a very good and very high CRI, bigger than 90 all over the line, and we are going along the Planck locus, exactly along the Planck locus, because we have not 2 points to realize a line. We can prepare really a curve along the Planck locus only with 3 points which are calibrated. And we have a McAdams factor smaller than 1, or in the near to 1, and it's a very good scene, in my opinion, in that kind of industry. So as I told you, we are able to shift the color temperature in between 2500 to 7000 Kelvin, and also with special products in between 1800 and 15,000 Kelvins. So this is the whole range, and our coloring index is bigger than 90. So the coloring index is very important for the perception. So if you want to have a whole spectrum in the same procedure like the natural daylight, so you need a full spectrum, and the higher the CRI is, better you will have a better lighting solution. So what you have to look is always to have a high CRI. So in the laws you can see always maybe for industry and also for workspaces minimum 80. In my opinion it should be minimum 90. So what you can see here is the typical CIA distribution. So you can see here the Planck locus. It goes from 1500 to 10,000 Kelvin. And what you can see with the 3 black lines, you can see the PLED triangle. And our technology is called PLED, and PLED stands for phosphor innovation. And you can see we are in between the triangle. We can not only realize high quality white light in between 2000 and 7000 Kelvin, we can also realize all kind of RGB colors in between the triangle. So let me say it's only for play with light. It's not really a working light. It's only to have maybe effects in a room and so on. So the typical spectrum of our LED is like that. You can see in the middle, close to 560 nanometers, is our green LED. The green LED is always switched on, has a very broad spectrum, and we need the blue and the red LED only to shift the color temperature between warm white and cold white. So we have a continuous luminous flux. For example, the standardization of tunable white technology with warm white and cold white LEDs has a big disadvantage. When you shift the color temperature into a very warm scene, the problem is that the other LED, for example the cold white LED, is switched off, and so your luminous flux is the half and the luminous intensity is not very high. For us it's very important to have a continuous luminous flux all over the lifetime and all over the color temperature shift. So with our mother company Lumitech, we are producing components. So we have a factory in the south of Austria together with a partner from the Zumtobel group. It's called Tridonic, maybe you have heard it. So we have together a big production line to produce LED chips. So the whole production of our products is in Austria located and not in China. So we have a different kind of systems. So for example, this is not the luminaire, these are only components, there are only components visible, but important is with our company Lumitech, we will support also lighting designers to prepare special solutions, and we will sell our components also to lighting luminaire factories out of Europe. We do also have a lot of lighting management systems, for example wired and unwired lighting management systems, but I will show you that kind of light management system in the next slides. So wireless communication, we do use the, maybe you have heard it, the Zigbee standard. So why wireless communication? In my opinion, we do use it also for refurbishment projects. In my opinion, it is very important to have that kind of technology. Maybe in Austria we have a lot of old buildings and it's not possible to do the wiring for the lighting management communication in between the control unit and the luminaire. So we have to find a solution to use the normal installation and to use also human-centric lighting. But when you use human-centric lighting, let me say, or if you want to shift the intensity, if you want to shift the color temperature, if you want to shift the color, so you need a lot of signals. So you have to do a separate wiring to realize that kind of application. And our intention was to find a solution to do that wireless. But in my opinion, at the moment in the market, it's only interesting for refurbishment projects or for small, or let me say, small projects. Otherwise, we are using wired solutions. In my opinion, in big buildings, it's the standard, the normal standard, it's DALI, maybe you have heard it. DALI stands for Digital Addressable Lighting Interface, and it's a light management standard which allows to communicate also with big light building management systems. But what you need is a gateway to translate from the building management system directly to the luminaire. So this should not be a product training or something like that. I will only show you that we have meantime a big portfolio. You can visit it also on the homepage. We have recessed luminaires, we have luminaires, suspended luminaires, we have profiles, we have luminaires for shop, and we have decorative orientated luminaires also. And also the lighting management systems, but it's not very interesting. What I will show you now, I think I have to look at the time, yeah. What I will show you now is we have developed a very interesting product together with a designer. It's called Studio Ocular. The product is called Vibe. And in my opinion, what is very interesting regarding this luminaire is that the natural daylight, so you have seen solutions, we also have that kind of solutions, but you have seen maybe you can shift the color temperature between warm white and cold white, or you can change the color. But in my opinion, the natural daylight, when you have a look in the sky in a clear, or let me say a very sunny day, so you do not only realize one color temperature, but as you know, the normal sky do not have the same color temperature as the sun. So for example, if you have a very sunny day, the color temperature of the sky is, for example, 10,000 to 7,000 kelvins, very blue dominated, and the sun, for example, is only 2,700 or 3,000 kelvins. So you have a big shift in between the color temperature. What we have done is to realize a luminaire with two different kind of lighting distribution. So you can see, I will show you now a short video. It will take only 2 or 3 minutes. But what you can see is you have a direct and an indirect lighting distribution. So inside are two different kind of LED modules, and the curves behind are not the same. So with the indirect lighting distribution, we want to bring in the lighting simulation of the natural daylight, the blue on the ceiling, and otherwise we will simulate the direct sun, for example, on your workspace or on the meeting table. So I hope it will run now.
Für mich ist Licht der Baustoff, mit dem ich eben arbeite und entwerfe, und die BLED-Technologie ist der beste Baustoff derzeit am Markt in diesem Gebiet. Und die Idee, die Sonne in den Raum zu holen, wird natürlich auch die Architektur nachhaltig verändern.
Ja, Ausgangspunkt unserer Produktentwicklungen ist immer das natürliche Tageslicht, das das beste Spektrum bietet. Und wir versuchen immer in unseren Technologien, in unseren Produkten, die spezielle PLED-Technologie zu implementieren. Das ist eine Technologie, die es erlaubt, das natürliche Tageslicht künstlich bestmöglich nachzubilden.
Im Dialog mit KITEO haben wir festgestellt, dass das Produkt zur Technologie fehlt. Die Leuchte Vibe holt quasi die Sonne in den Raum. Man kann den gesamten Tagesverlauf nachzeichnen.
Im konkreten Produkt der Vibe wurde das so umgesetzt, dass die Technologie zum einen direkt und zum anderen einen indirekt Anteil ansteuert und dadurch die Möglichkeit geboten wird, den natürlichen Himmel, der aus zwei Teilen besteht, nämlich aus dem Horizont und aus dem direkten Sonnenlicht, direkt nachbildbar ist, und zwar getrennt voneinander. So hat der Nutzer die Möglichkeit, wirklich ein komplettes Himmelbildszenario, nicht nur statisch, sondern dynamisch in seinen Räumlichkeiten zu erleben.
Die organische Form folgt dem Licht und es entwickelt sich quasi eine Lichtlandschaft, die natürlich auch auf den Raum abstrahlt und den Raum verändert. Die Möglichkeit, mit künstlichem Tageslicht zu arbeiten, ist natürlich enorm spannend aus Sicht der Architektin. Die Vibe gibt dem biorhythmischen Licht seine dynamische Gestalt und es macht mir enorm Spaß, an dieser technologischen Entwicklung teilzunehmen.
Es ist dann in der Leuchte ein von uns erforschter, von uns entwickelter Tageslichtablauf integriert, der automatisch abläuft. Dennoch hat der Nutzer aber für bestimmte Stimmungen die Möglichkeit, individuell in die Lichtszenarien einzugreifen und kann mit den Bedienstellen individuell seine gewünschte Lichtstimmung parametrieren und genießen. So, yeah. So this was our, let me say, answer of human-centric lighting. So it's a little bit of confusion, I think, so in the first moment. But our idea was really to simulate the natural daylight in indoor lighting. So this was our first, let me say, decorative-orientated luminaire. So normally we have only technical solutions, but in my opinion, a very interesting solution to bring in natural daylight into indoor lighting solutions. So we have a lot of different kind of applications. I will give you only an overview. So our typical application, let me say, we are very strong in Germany, Austria and Switzerland. This is our main market, and we have partners also in Scandinavia and in Benelux. So this is our main workspace, let me say. Offices and workspaces, also education. For example, also in Scandinavia, education is very important. They spend a lot of money in that kind of solutions. Healthcare is in Austria a very famous investigation part, let me say. Home and wellness, yeah, in home and wellness the natural daylight solution is not so important, but what important is the light quality and, let me say, the functionality of light regarding to define different kind of light scenes. And you have always to use, for example, in home applications, you have to use wireless communication. For maybe in Austria, I don't know what the famous communication tool in Romania is, but I think you have also 50% maybe wireless and 50% wired, I don't know. Yeah, also very important for us is the shop area and hospitality, but in the shops and hospitality, daylight is also not so important. Very important is the light quality and the color rendering index. So in our project we have always to define the correct color temperature and the correct color rendering index, and normally in Austria you need coloring index minimum 90. So human-centric lighting is a growing business, let me say. There is a very interesting study. It was developed by A.T. Kearney. It's a company from the US, and as you can see here, the curves figure out that in the year 2060 there is not so a big market share, let me say, of human-centric lighting, but in my opinion in the next 5 or 6 years the topic human-centric lighting will become quicker and quicker and will be important in every project. So in my opinion, we founded Lumitech since 20 years before, and we spent a lot of our time and money in the technology, and in my opinion in the next few years we will earn the costs also, and also the specialty of the technology PLED. So finally, I've seen yesterday there was really a great event in that gallery, and at the end I will show you, let me say, an artificial installation. So that was on at the Fair Light and Building in April, and what we do not have a booth at the Light and Building, but what we have done is to realize a light path. So it's a truck with a natural daylight solution inside. So we have created it with Fritz Biedermann. It's an artist in Austria, especially for light solutions. And what we have done, we have to define a solution to transport the light from Austria directly to Frankfurt, and our truck was based in the first district of Frankfurt with that kind of lighting installation. And what we have done is we have tried to find a camera obscura. Maybe you know that it's a reverse camera, so you have the possibility to go inside the truck and to feel a continuous daylight solution in 2 minutes. So I have prepared a video. I will show you finally the video I have prepared with my handy, so it's not HD quality, but I think you can imagine what was going on. And our opinion was, at the first time we will have maybe 30 to 50 visitors per day, but finally we have in 1 week 8,000 visitors in the truck. And you can see only the picture of the truck before the event. After the event, the truck was totally damaged, let me say, because we did not expect so much visitors. Thank you very much. Thank you. Have a nice day and a good event.